So, just a quick sort of heads up on what I'm going to be covering. Recap of what MCS is for anybody who's not familiar. They might have seen the logo around, but you might not necessarily know what that logo actually means, what it stands for. And it isn't just a logo that you can buy and stick on. There's actually quite a process to go through, either if you're a product supplier or manufacturer, or if you're an installer as well, because it covers both. So I'll talk about that, why it's important in the UK a little bit, I'll touch on, and recent changes, because it's an ongoing process. The working groups and the standards committees are meeting regularly, and the standards are continuously evolving as we get more information and feedback from the industry. So in its simplest form, what is it? It's really just a certification mark, it's a quality mark. Some people think that it's part of the feed-in tariffs, or it's part of some other subsidy scheme. It's not really. It's an independent quality mark for both products and installers, and it stands on its own feet, if you like. And feed-in tariffs and other incentives may come and go, but the MCS will always be there for example, to be called up in contracts when people are letting contracts out. So it's a permanent thing, and it's not, although these other schemes like feed-in tariffs do call it up, it's not bound up with those schemes, it's independent. I mentioned the working group that I sit on, that's actually run by industry itself. So people within the industry come and volunteer their time to sit on the working groups and make the standards better as time goes on. I think Ray mentioned, I just wanted to emphasise actually, MCS is set up really to cover systems up to 50 kilowatts for products and installers, because it was initially set up thinking that this would probably only apply to domestic premises and maybe small businesses, which takes you up to around about 50 kilowatts. And there isn't anything currently above that, so that's another thing that the National Solar Centre is doing. The code of practice that Ray mentioned is currently being written, and so 50 kilowatt systems and above will have a code of practice then to call on, and that will no doubt also get written into contracts. We don't know yet whether the feed-in tariffs or ROCs will call it up, but initially we just need the code out there. So why is it important in the UK? Because we've come from nothing to quite a largish industry in no time at all. The confidence in products and installers is absolutely crucial. It's so easy to kill the market off with some simple mistakes, with poor products or bad installations. We've seen a few cowboys out there on the installer side especially, and we've got to eradicate that. And this is the main goal of MCS really, to really nail down that quality. But it has these other advantages as well, as you can see, access to fits obviously. The feed-in tariffs, you can't get them without MCS. Helps reduce carbon emissions because it's aimed at getting people to do things in the right way, so you don't waste energy by installing these things. It protects from mis-selling, improves the information and awareness out there generally, and that's also where the National Solar Centre is headed, and enhances public safety because we will only allow installers who've been through quite a rigorous process to install. So how's it different? You know, a lot of people when you come to shows like Intersolar say, well, why would we need MCS? You know, we're okay in our countries the way we do it. And there's a lot of different schemes out there. If you look across, I've only really sort of looked across Europe, I suppose. But even across Europe, there's a huge variety of different systems out there. There are some certification schemes. Largely, they tend to involve just attending a course, passing an exam. It might have a practical element, might not, and then you're through and you're a bona fide installer. Sometimes you have to submit documentation of some of example projects, or you might just sign up to a charter to promise to do things in a good fashion. You know, there's everything out there, but often it's not certified properly by a certification body. And it's an unaccredited training course. So MCS is a little bit different. It's quite rigorous, and it is accredited. I forget the EN number actually, but it's accredited to an international EN standard, as all proper certification schemes are. This is the structure, or a simplified way of thinking of the structure of MCS. So it requires a quality management system. Doesn't matter if you're an installer or a product manufacturer, you have to have that. If you're an installer, you have to sign up to a consumer code, which is all about treating the customer fairly in terms of the contractual arrangements. If you're a manufacturer, you're subject to factory inspections, production quality control techniques. And then the last blob on there, which I'm going to speak about probably mostly, are the technical standards, which ensure that there's technical rigour built into MCS. And that, for PV, that translates into a suite of standards. There's a quality management system overarching document, MCS 001, which basically talks generically about the requirements for your quality management system if you're an installer. The technical document for installers is MIS 3002, and that's recently gone a radical upgrade. It used to try to incorporate quite a bit of the technical information required. That's all been stripped out now, and it just refers to a user guide, an installer's design guide, which is just been published. So I'll talk a bit more about that later. And the real assurance code that's mentioned there is the consumer code that I was talking about, and it's the only one that's around that's been approved by our Office of Fair Trading in the UK, but there's nothing to stop other consumer codes coming along and giving them some competition. For manufacturers, there's a standard for modules, and I'll go into most of these standards in a little bit more detail further down anyway, so I'll just read through these now. There's one for pitch-groove installation kits, bespoke BIPV, and then the factory production and control and whose tests can be accepted are also buried in another couple of documents, MCS 10 and 11. Don't get too hung up on the numbers of standards and stuff at the moment. We'll just need 2 or 3 standards most likely for your particular business, and they're fairly easy to identify. So back to that structure, just looking at the main boxes there. I'm just going to have a couple of slides on the quality management system. Some of you will be fully conversant with quality management systems like ISO 9001, and you can go to sleep for the next 2 slides. I just thought I'd say a couple of things because a lot of people don't really understand what's encompassed by a quality management system. It applies to, as I say, installers and product manufacturers. But it's really all about consistent quality. If you have a process which is written down, whether you're an installer or a manufacturer, you've thought it through, you actually practice what you've written down, and you get audited against it, then that automatically really results in consistent quality because you can only do things one way. If your business gets interrupted due to illness or injury or whatever, then there's a system, a written system there that people can refer to, and somebody can pick up the reins and carry on running the business at that time. And staff training, it's obviously much easier to take on staff if you've actually got a written system that you can point them to and say that's how we work and that's how we expect you to work. And from a certification body point of view, it makes your business auditable so that we can come along, see how you work, check you are actually working to those procedures, and perhaps go and either visit the factory or visit some installations to prove that it's actually happening in practice and you're not just paying lip service to it. So simply said, you've got to say what you do, in other words, have written procedures to say how you're going to work, do what you say, and then prove it by showing your MCS certification body exactly what you've done in particular cases. Enough about quality management systems. A slide on the consumer code as well. It's not really what I'm here to talk about, but it's really just I show you the type of thing that's involved in that. You have to sign up to this if you want to be an installer in the UK. It doesn't affect manufacturers. It's really just a promise that you're going to give clear information, that you'll use acceptable sales tactics, that your conditions of business are fair, and there are some requirements on guarantees and after sales services. One of the really good things that the real code, as this is referred to, does is will arbitrate in the case of a dispute. So if there's a problem out there, and it can't be resolved between the client and the installer and the client and the distributor or manufacturer or whoever's involved. REA, the real code, will step in and do some arbitration. Right, now on to the last box on there, which is really mostly what I'm involved with. From manufacturer's point of view, the standard is pretty easy. If you've got your ordinary IEC testing done, the IEC 61215 or 61646 for thin film, there's very little else to do. It's a little bit more documentation, and you'll have to submit the test reports to the certification bodies. They can make sure they're genuine. And it says a few things about roof integrated products, like how you've got to specify how you'll achieve weather tightness. So really not a big deal, MCS 005 for product manufacturers. This is a new one, pitched roof installation kits, MCS 12. Again, this is for manufacturers, and it's really it evolved because there was some concern in the domestic market about whether PV systems would affect the integrity of a roof. That's why it's pitched roof of your average domestic property. So, you know, they could blow off the roof, they could be a fire hazard, they could cause rain ingress, various issues. And so that's been well and truly nailed down with this new standard, MCS 12. And it really defines the tests you have to do to prove that you have fire resistance, appropriate fire resistance, wind uplift tests, and rain ingress tests. And this applies to any kit for mounting. So if you're a mounting producer and you want to sell into the UK, you need to get your system through MCS 12, and you may well need to specify the types of solar panels that it's compatible with as well to get it through. It was introduced some time ago now, about 15 months ago, I think, and at the time they said, well, we don't quite know how this is going to play out, so we'll do a review in about 15 months' time, and that's about now, I think. So if anybody has any comments on this standard, having read it, it's a good time to feed it into MCS now if you want to have your voice heard, because the review is about to start, I believe. The other one for manufacturers is really if you're into BIPV, building integrated PV, and this new terminology, BBIPV, is bespoke. In other words, that's customised. So if you're doing something like glass laminates, or you're designing your panels specifically for a particular development or particular building, then you're doing customised ones, which in UK jargon is called bespoke. It's an ancient term dating back hundreds of years, and it's about tailors, I think. So you'll need to get your product through this, and it's actually a pretty good thing because it's aimed at deliberately allowing certain variations on a building. So you might do a building with 6 or 7 different styles or types or sizes or thicknesses of glass. If it's all customised, they could all be different on the building. And this standard MCS 17 actually allows that, and it tells you what you can vary and what you cannot vary to still be MCS certified for your product. On the installation side, this list of things here really generically shows what all of the installation standards under MCS cover, and that covers all of the technologies. So it's not just PV, solar thermal, biomass, wind turbines, heat pumps. They all cover pretty much the same sort of areas. But we look pretty carefully at the capability of the contractor. We check they've got their quality management system in place. We look at their subcontracting arrangements, because the company that's certified actually has to remain responsible for the installation. It's no good them saying, okay, we subbed that one out, and we know it's a mess, but it's not us because it was a subcontractor. That's not acceptable under MCS. MCS wants to see proper control of subcontractors, and the subcontractors are trained according to the MCS requirements. And I mentioned the consumer code of practice, and then obviously there's stuff like regulations, some design rules, which are now stated in the new installation design guide. that's come out. The competence of staff, we're tightening up on. It was, until recently, quite loose. And later versions of that, especially going forward from now, will start to tighten up and say which particular competencies must be tested, which people must have gone on courses for. So that's getting tighter and tighter. And again, it's all about sort of just raising the standards, raising the quality in the UK marketplace. Back to the PV, that was generic. I was just talking about pretty much all installation standards there. The PV installation standard, the technical one. We had our new version released in February this year. It refers to the installation guide, which I'm going to come on to. And a couple of key points in it. It now has a much better method of energy estimate, which you have to give to the client before they sign a contract with you. And the other one is wind loading. There was quite a lot of confusion in the market before about exactly how to calculate wind loading caused by PV on roofs. So that's a picture of the front page of the new guide. And the list there is some of the new subjects that it either covers. Most of their updates, actually. There are one or two new topics, but mostly they're improvements on the advice that had gone before. The old one was getting pretty dated. But I say the two key areas now really are these performance estimates, the wind loading calculations, are key to the whole thing. But we've also tightened up because transformerless inverters, for example, have come along in the meantime since the last one was released. And so what you do about those in terms of earthing requirements and protection, electrical protection, that sort of thing is all covered in there. I don't propose to go into all of that detail now because I don't have time. But I'll just give you a quick flavour of what's involved in this new energy estimate method. It's pretty simple. The equation at the top there says your AC output over the year is going to be the number of kilowatt peaks you've got. That's the size of your PV system. Multiplied by these two other factors. The KK factor you can just get from a table, and you get that by looking at what region of the UK you're in. So the zones on the left are the zones in the UK. You work out where you are. That sends you to the right table. And when you found the right table, you can then look up the number of kilowatt hours per kilowatt peak you're likely to get out of that system, assuming there's no shading at this point. Okay, so there isn't just one table, there's an awful lot of those tables, but they're all available free for download on the MCS website, so it isn't a big issue to do that. So that's very simple so far. You just look up your region, you get your kilowatt hours per kilowatt peak, and then you have to look at the shading of the site, which is traditionally the thing that really catches installers out, especially if they're inexperienced. Experienced installers understand that nonlinear effect. You know, you shade a little bit of a solar panel, a little bit of a PV panel, and it takes out most of your energy. Some of the people new to the market didn't really understand that. So we've introduced this new estimate. It's not as good as a modelling package. It's not intended to be a PV Syst or a PV Sol or a RET screen or one of those. It doesn't take into account all of those factors that those modelling packages do take into account. But what this is a simple system that you can do on paper, and it's auditable by the certification bodies. Those are the key things about it. It's based on, this is a sun path. Path of the sun, the lower arc is the path of the sun in the winter. The upper path is the path of the sun in the summer. And you can see there's an obstruction being put on there. Looks a little bit like the gherkin in London for some reason. I have no idea why. And that gherkin is touching a number of squares on there. And what you do is you assign a value of 0.01 to each square, add them all up, and that tells you how much shade you've got from the horizon. Okay, and then you subtract that from 1 and it gives you a shading factor, which is a nice, simple, easy way to do it, as long as your sketching is reasonably accurate, and you do need a compass and probably an angle estimator as well to actually get the sketch fairly accurate on there. But as anybody who's been in the business a few years, especially if you're an installer, knows, that's not the end of the story, unfortunately, for shading, because that gives you your loss of direct beam radiation from the horizon. It doesn't tell you anything about the chimney that's right next to you, or an air vent, or a dormer window, or a satellite dish, all of those things that just clutter up the roof. and those are actually much more significant in terms of shading because they cast sharp shadows on your PV. So we had to address that as well. It's a particularly difficult thing to address. And so what we came up with really is you measure the angular height of any obstructions that are close, that are going to affect your PV system, from the position that's most affected. And then you draw that angle onto your chart and draw a circle the same radius as the height of your obstruction. And you can see that's highly punitive. Suddenly the shading factor, I haven't put it on here actually, for some reason I should have done, but you can see the shading factor has gone up enormously, or the shading coefficient has gone down. In other words, the shading is much more significant all of a sudden. It's a quick, cheap and cheerful way of getting an estimate of that, but it actually should deter people from putting solar panels in the wrong place. That's the whole thinking behind this. If you've got a satellite dish, don't just stick it next to it where the satellite dish is going to shade it. Move the satellite dish and then put your system up. If it's a chimney on an old house, you might be able to remove the chimney altogether. That happens quite a lot. So that's why this particular methodology is quite punitive. I mentioned the wind uplift also. There's a simplified method of that now. This can get horrendously complicated for anybody who's actually done the calculations. But there's a simplified method now within the MCS guide, and you can again look up some pressure coefficients from, there's a BRE document called BRE Digest 489, which has been out many years now and is very well established. You can then look up the dynamic wind pressure QP it's a European standard actually, BSEN 1991. Most people know it as Eurocode 1. Okay, so I don't want to bore you with all the technical details of how to do these calculations, but really the key point is there's a simplified method now in the new MCS guide, and it's very good. It's quite conservative, but it works very well. It also takes account of things like whether your building's on a hill or halfway up a hill, and the various safety factors that you have to build in to that. Helps you again with the roof structure as well. As I say, it's a guide, it's a simplified guide, and it gives you a couple of examples. If you've got some very standard roofs, these are typical roofs in the UK. The first one is a standard trussed roof, a more modern roof. Second one down is a thing called a cut roof, which is the older style we have in the UK. And it gives you some guidance. If you've got a standard roof of that sort, you can make certain assumptions about the loading that it was designed for, and you look at the actual weight of tiles that are on there at the moment, and you subtract one from the other, and you can work out what loading you have available for your PV. It's a very sort of simplified method, but the key thing that we do emphasise time and time again, if there's any doubt whatsoever, you need a structural engineer to come and do a report on it, and that's obviously the most surefire way of handling these things. Documentation and commissioning requirements in MCS have gone up quite radically as well, because it now refers to EN 62446. We have a British standard version of that, which is just BSEN 62446. But it's quite stringent on what documentation must be handed over and what commissioning tests must be performed on any system conforming to this standard. So take a look at that and get that one. It's reasonably onerous, but very, very good actually. And again, will certainly help to raise the quality of installations in the UK. So I said I'd mention where to get the MCS documentation from. Bit of a mouthful, it's www.microgenerationcertification.org. And everything I've spoken about today you can find on that website. I will just say the photograph at the top there is a photograph of our innovation park at BRE in Watford, and you'd be welcome to come along and have a look around that. The innovation park is full of low energy buildings, state-of-the-art materials, some renewables as well. Okay.